This is the second mini lecture for section 2.3 of the textbook. We're going to continue our discussion of the properties of addition with whole numbers. You'll remember these properties are supposed to be things that you're familiar with. They're kind of obvious to you, but perhaps you've never seen the names for them before. The words are kind of long and maybe not commonly encountered when you were growing up. You'll find when you teach that they do come up quite a bit in teaching nowadays, and you will probably be teaching these words. That this may be the first time you're seeing some of them. Just remember that we're just trying to put names to things that were sort of already obvious. Now the third property is called the associative property. Let's talk about its meaning. Addition is what we call a binary operation. That's what the book refers to it as. That means that it accepts two inputs at a time. So think about if you're trying to add three numbers all at once, a plus b plus c. What does that mean? Well, no matter how you try to add that on paper or in your brain or using a calculator, you have to start with just two of the numbers. You cannot add all three at once. Even in your mind, your brain just doesn't work that way. You can only do one thing at a time. And adding three things is really doing two things at once. So you have to pick where to start. Are you going to add the a plus the b and then add the c onto that? Or are you going to maybe begin by doing the b plus the c and then you add that to the a? So no matter how you do that, you want to make sure that the answer is not going to depend on the order that you went in. If it did, if the order made a difference in the final answer, you wouldn't be able to write something like this without parentheses. It would have no meaning because it would depend on where you started. But it is true that a plus b plus c, written like this, where we mean first to add the a and the b, is the same as a plus b plus c written this way, where first we add the b and the c. Okay, so this is called the associative property. The fact that this is always true is the associative property. Here's a good way to remember that word. The B gets to decide whom he wants to associate with, the A or the C. In other words, who does he want to be friends with? Does he want to be friends with the A, like here, or does he want to be friends with the C, like here? Well, the property tells us that it doesn't matter. He can pick either one, and the answer will be the same regardless. So for example, 4 plus 2 plus 3 equals 4 plus 2 plus 3. There are two different ways to illustrate this. The first is with fraction strips. Okay, so I'm going to draw a picture like you would draw on your homework. We have 4 plus 2 plus 3. I just draw those three numbers side by side. And since I have 4 and 2 in the parentheses, I'm going to begin by putting the 4 and the 2 together. Okay, and for now the 3 just stays on its own. Okay, but now I put the 6 and the 3 together. That gives me 9. Okay, on the other hand, let's do 4 plus 2 plus 3 the other way. I begin the same way. We draw the three numbers side by side. And 4 is going to just be retained for the time being. I'm putting the 2 and the 3 together first. Now I add together the 4 and the 5 that resulted. That gives me 9 again. So this is number strips. I can also represent the same thing using the number line. Let's try that down below. Yeah, I'll do it on both sides like we did before. First, let's do the left-hand side, the 4 plus 2 in parentheses. So I begin by adding the 4 and the 2. Okay, those combine into a 6. And then to the 6, I'm adding a 3. So what we're really adding is 6 plus 3 here. Okay, now let's do it the other way around. I'll start with the 4 and then add that to the 2 plus 3. So we've got 4 and then the 2 plus 3. So I'll put a 2 and a 3. But I'm going to combine those together first now to a 5. And so what we're really adding there is 4 plus 5. Let me say a couple things about the two of these. For both of them, notice that this, I really need all of the numbers present. I can't just draw the answer. Like when I was doing the number strips, it would not be enough to just draw the 3 numbers and then the answer. If what I'm trying to do is illustrate the associative property. Why? Because that doesn't show me that there's 2 different ways of adding this. If you're trying to draw this, what's really important is that you have this intermediate step. Similarly down here, you need the 4, the 2, and the 3, the 4, the 2, and the 3. That's really important. Equally important is to have this 6 and this 5. If you were to just have the 4, 2, 3 and 4, 2, 3, you're not showing how the associative property is applying here. You're just showing here's the sum and here's the same sum. So I want to see the 4 and the 2 combined and the 2 and the 3 combined. Also, notice that the order stays the same. 4, 2, 3, 4, 2, 3. Don't mess with that. Okay, if you start changing the order of the numbers, you're bringing in the commutative property. And we're trying to just illustrate the associative property here. Okay, so finally, there's a unique whole number, which we call 0, so that a plus 0 is equal to 0 plus a is equal to a for every a. That number 0 is called the additive identity. So altogether, we have these 4 properties of addition: the closure property, the commutative property, the associative property, and the additive identity property.